Alrighty, I've been using these words explanatory and response variable for a while. It's probably about time that I actually tell you what they are. So the best way to think about it is that your explanatory variable is your X or your independent, whereas your response variable would be your Y or your dependent. So basically, if you wanted to measure, how income affects the value of your car, well, which do we think makes the difference? Is having a higher income going to mean that you're going to have a different, more expensive car? Or is it that having a more expensive car means that you have a higher income? Well, unless your job is somehow to do with driving, you're probably more likely to, if you've got a more income, then that means that your car value is probably going to be more. So let's think about that from this terms. So that means we can say that your income explains how much your car should be worth, or vice versa, how much your car is worth should respond to how much money you make. For example, if you only make a couple of $100 a week, you're probably going to be buying something more like a Suzuki Swift than you are probably going to be getting a Lamborghini. Whereas if you're the CEO of, say, Tesla, you're more likely to be driving a Tesla. So you could understand that your income probably affects that. So what we're going to be looking at these is thinking about some quick examples and thinking about, okay, well, which actually affects which? So which is my explanatory variable and which one is my response variable? So age and wealth. Okay. So do we think that as you change age, your wealth might change as well? Or well, being older might affect how much money you've got? Or do we think having more money is going to affect your age? Well, that doesn't make any sense. Having more money doesn't make you older. So that means in this case, age would be our explanatory variable, while wealth would be our response. Alrighty, what about age and the number of offspring? Well, once again, as you get older, you would have more children maybe. That's offspring's just another word for children. Or as you have more children, you get older. Well, I'm sure some parents believe that as they get more children, that they get more grey hairs, but I don't think it actually changes the rate that you age. So age, once again, will be the explanatory variable, while number of offspring would be our response. Alrighty, temperature of the day and number of people at the beach. Once again, which affects which? Does the temperature affect how many people go to the beach? Or does the number of people at the beach change the temperature of the day? Well, it doesn't quite make sense going the other way. It makes more sense to say, well, on a cooler day, there's probably going to be less people there. And on a warmer day, there's probably going to be more people there. To a certain point, at least. When it gets really, really warm, maybe no one wants to go out. So, temperature would be our explanatory, while number of people would be our response. Number of cigarettes smoked and the chance of getting cancer. So, number of cigarettes smoked and the chance of getting cancer. Well, as you smoke more cigarettes, is your chance of getting cancer higher or lower? It should be higher. So that means the number of cigarettes would be our explanatory variable, while the chance of getting cancer will be our response. Alright, and the last one says, the volume of petrol remaining in a car's tank and the distance the car has been driven. So as the amount of petrol in the car's tank goes down, the car has driven further? Or the further the car is driven, the less petrol is in the tank. And we can see that in this case, it's actually, this will be our explanatory variable, because the more you drive your car, the less fuel you'll have, while this will be our response. Okay? So it's really important to be able to identify which is which. Alrighty, so there we go. Before we move on though, I do want to talk about a third type of variable, alrighty? And that's called a confounding variable. So in our simplistic picture that we've got is that the explanatory variable affects our response variable. Alrighty? Now that's a really simplistic picture because basically what we're saying is we've got one factor affects the response variable. Now obviously we could find out that there's actually multiple explanatory variables that all affect our response variable. That makes perfect sense as well. But sometimes we get two variables and then it doesn't actually make sense to call one of them the explanatory variable and the other the response variable because really they're not the ones directly affecting each other. In this case, we might find that the two variables don't actually affect each other, but instead that there is a third variable which we can call our confounding variable. And our confounding variable is just a variable which affects both of the variables we're measuring. So a simple example might be the number of hospitals in a city and the number of driver's license in a city. Well, really, the more driver's license in the city doesn't really affect how many hospitals there are, and how many hospitals don't really affect how many driver's license there are. But yet you'll notice that there's actually an increasing trend regardless, as though it looks like they're affecting each other. But the reason that is there's actually a third variable that's actually controlling both. So if you've got more hospitals and you've got more driver's license in a city, what does that really tell us about each city? It tells us the population. As the population of a city grows, well, there'd be more people on the road and there'd also be more hospitals need to be built. So you can kind of see how confounding variables can sometimes get mixed up sometimes in this. So making sure we're really able to identify things like that as well. Alrighty, I'll see you in the next one. Goodbye.